In this video, we're going to explain how to connect the DS18B20 digital thermometer to our Arduino-based data logger system. Now this DS18B20 is a very popular temperature sensor to use with things like the Arduino or Raspberry Pi. Because it is a digital thermometer, you query it and it sends back the digital words representing the temperature. I have the data sheet up here on the screen right now. It typically comes in a couple of different packages. Most people use it in this TO92 package that I'll show you here in a minute. It only has 3 leads: ground, power, and data. And this chip uses a unique interface called a one-wire interface. And what's cool about that is each one of these chips has a unique 64-bit serial code, and so they're all unique. And so what that enables you to do is connect them all together in parallel or in long chains, and then the data logger can query those and read large numbers of them using only one single data pin that's connected to the data logger. That is, you might have 20 of them in a chain and only 3 wires coming back to the data logger: ground, power, and signal. And so that's one thing that makes them really unique. They used to be called Dallas, owned by a company called Dallas Semiconductor. Now they're owned by Maxim. They have good temperature range from -55 to 125. And they have a lot of other nice features. They can be powered. They have a resolution of up to 0.625 degrees C when operated in 12-bit mode, and typically have an accuracy within half a degree Celsius. We found that they're often quite better than that, especially if you check their calibration ahead of time in the laboratory against a standard. So they're very suitable for research grade work, especially if you need a large number of temperature measurements in one location. So let's go over here to the down-facing camera, and I'll show you. Here's one of the actual sensors in that TO92 package. Again, only 3 leads. You can see it's quite small, typically about 5 millimeters across, and easy to put in some kind of protection tube. Again, each one of these will have a unique serial number. Often you buy them in like this. Someone's already put them in a tube, filled it with epoxy, put a lead wire on there, and here's your 3 leads here that then you can connect to the data logger. So that's pretty handy. It's sometimes you can buy them for the same price already packaged if they're suitable for what you're interested in. This packaging is pretty large, so it's going to be kind of a slow response sensor. Keep that in mind. Great for things like water, soil, water baths, things like that, ovens, but maybe not suitable for fast response measurements. You can also buy your own protection tubes and then just buy the sensor, buy your own hookup wire, solder those on there, put some heat shrink on them, and then fill this with epoxy and pot that down in there yourself and make your own sensors. It's also possible to hook them up in large chains like I mentioned before. That's kind of a really unique thing about this sensor that you can't do with something like thermistors or thermocouples, at least not easily. And we'll talk about that maybe in a later video. I'll show you how to set up that particular configuration. Let's talk about how we're going to hook this up to the data logger. So here's my Arduino system. Our Uno with the breadboard. I'm going to go ahead and put one of the sensors on here. When you're trying, remember, one of the first things you have to do is find the serial number of all these, because that's not known when you purchase them. So one of the things that you have to do a lot of the time is set up a little circuit so you can just identify all the serial numbers. If we look at the wiring on this, I'm going to need power and ground, so I'm going to get 5 volts over here on the board and put it on the side of my breadboard just to get started. And I'm going to need ground. Okay, then let's go ahead and hook up the sensor. I think I'll move it here a little bit closer. The very right hand leg is power. The left leg is ground. Make sure you keep the orientation of these correct. If you hooked it up backwards, for example, if I flipped it around, the chip will start heating up. Let me use a different colored wire there. I always like to use black or green for ground. Okay, then we need a 4.7K resistor jumpered between the signal wire and ground, or excuse me, between power and the signal. And then the signal itself is the middle pin. And I'm going to hook it up here to 01 pin 2, digital pin 2. Let me move this over here just so it's a little easier. Okay. So now my system is connected. That should be okay. And we can run a test program now to see if we can read the address of this sensor, which I've labeled sensor number 5, just to help me keep track of what the serial numbers are. Okay, so let's move over to our Arduino IDE. And we're going to need 2 libraries to read this sensor. So go to Sketch, Include Library, Manage Libraries. The first library that you'll need is called OneWire. Here it is right here. This is the interface, the library that helps you access these OneWire temperature sensors. Mine is already installed, but you just need to click on that and then click Install. The other library that you need is this one called Dallas Temperature. Okay, again, click on that. Mine's already installed, but click on that and install that. So you're going to need those 2 libraries to work with these sensors. Now let's go to File, Examples. Let's go down to the Dallas Temperature library, which should now appear at the bottom of your library list. And let's open up this program called OneWire Search. What OneWire Search does, it's just a handy little program that goes out and looks for OneWire devices and reports back the address that it found. Okay, which is kind of what we need now. We've got this sensor over here labeled number 5. We need to find out what its address is. Okay, so I'm going to hook up my Arduino to power. Always remember, while you're wiring things up, it's a good idea to keep things unplugged. So I'm going to go to Tools. I am using an Uno. I am on port 14. That looks okay. So I'm going to upload that. So it's compiling the sketch and uploading. I'm going to go to Tools. I'm going to go to Serial Monitor. And when you see garbage like that, it usually means that the baud rate's not correct. So if you look over here, the baud rate in the program is the 115,000. So I need to change this. There we go. And so it found one device. That's what it's telling me here. And here is the address right here. So that happens to be the address for the temperature sensor I've got labeled number 5. So I'm going to hit Control C right here and just copy it over here to a little editor that I have. Can't see it. I have it on a second monitor. I'm using Notepad++, and I'm going to keep my list of addresses over here, and I would probably put some kind of label on it, like it's label 5. Okay, so now I'm going to pull that DS18B20 out and put in a new one. This one's labeled 6. Alright, then I'm just going to hit the reset button on my Arduino, and it should run the code again, and you can see it found this one, and you can see these addresses are different. Okay, they're not the same. So I'm going to copy that, and I'm going to put this over, copy that over to a notepad. So, just open up WordPad or something like that and keep track of these. I have identified the addresses of the two sensors that I want to use for this example, and now I'm ready to wire them up and try to read them and output to the screen. So I'm going to go back to my down facing camera, and so what I think I'm going to do is put number 5 here back in the original position, and I'm going to move 6 out here. So 5 and 6. Okay. And now I just need to, I can connect them together just in parallel. So I can just, and I could just do this for a whole bunch of sensors if I wanted to. I've heard of people hooking up over 20 of these at a time, just daisy chaining them together like this. So now I've got 2 sensors in the system. Okay, now that we have the 2 addresses, we're ready to try to read the sensors and output the results to the screen. So I'm going to open up a new sheet here and work through what we need to include. The first thing that we need to do is add those libraries. You can actually do that here. Include library. We need the Dallas temperature one, and we need the one wire. Okay, and we'll put a little comment on the top just so we know what's going on. DS18B20 example. Okay, and we're going to read 2 sensors. So let's think about now what else we need to include. The first thing we need to do is define what pin we're going to use. That's what I'm doing here. Let's change this to pin 2 since that's where we're already wired. We're going to use pin 2 for all of our communication. That's why it's called one wire. We're going to define what we're going to call the one wire bus. This is a library word, but this is a word of our own choosing here. Then we're going to set up the sensor object. So one wire is coming from here, and this word sensors is of our own choosing. This is all, understanding all this is not terribly critical. The key thing is just knowing the parts that you need to make this thing work for you. Now we need to set up our device addresses that we found earlier. And instead of typing them, I'm going to paste them in here. But I'm saying device address inside thermometer, and that's going to my DS18B20 sensor number 5. Okay, that's the one toward the center of the breadboard. And then here's what I'm calling the outside thermometer, and I put in the address for sensor number 6, which is over here. Okay, so that's where we're using those addresses, and we're going to do like an indoor-outdoor thermometer example. The next thing we need to do is add some stuff to the setup. It's always a good idea to set up your serial port if we're going to output to the screen. We need to start the sensors or initialize them. Then we need to set the resolution. And we do that with these commands. It's called sensors set resolution. Want the inside thermometer at 12-bit and the outside thermometer at 12-bit. That's going to give us 0.0625 degrees C resolution. That's the smallest change that it can measure. That's pretty good. Remember, these sensors are fairly inexpensive. I forgot to mention that earlier. We're only talking about a $2 sensor here. Maybe cheaper depending on where you purchase them. So that should have started my serial port, and this should have got my sensors ready to use. Now we're ready to put something in the main loop. One thing we could do is compile right here just to see if it's going to compile. Need to give it a new name. Okay, and it did compile, so there's no errors or no missing libraries at this point. Now the first thing you want to do in the loop is actually request the temperatures from the sensors. So when you give this command, it actually goes out and requests the temperatures from all the sensors. We need to retrieve the data then and move it into two new variables that we've created, float variables called temp inside. See, it says sensors.getTemperature inside thermometer, sensors.getTemperature outside thermometer. So that's going to get those. So at this point we should have the data. So all we need to do now is print it out to the screen. So here we go. Serial print inside, then print the variable temp inside, serial print the label outside, and then print the actual results, and then add a carriage return. Only other thing we need is a little delay statement here, just to slow things down a little bit. So that should work. Let's indent this just to make it look good. Let's see if it compiles. It does. So that's looking okay. And let's see if we can download that and see if we get any results. Okay, it looks like we are getting some results. Looking pretty good there. They're both giving us very, very similar results. But you know, you want to make sure it's not actually reading the same sensor or something like that. I'm a little suspicious. They're so close together. I'm going to hit this sensor number 6 with this heat gun a little bit and see what happens. So I hit the outside one with the heat gun, and sure enough, it shot right up there. So it looks like it's working pretty good. Let me hit the other one. It should go up now, and it does. So it looks like everything's responding really nicely, and it was really great to see that when they first started. I'm going to stop the auto scroll for a second. That you can see this really good agreement between them at the beginning, only about a 0.06 degree difference. Okay, so that's really a good sign. So at this point we have a fully operational system for reading the DS18B20s, and in the next step I'll show you how to add the OLED display and use this for temperature control like a thermostat or a cooling system. But at this point you should be able to use that DS18B20 and start thinking about how you would incorporate it into the bigger data acquisition and control system.